Now this is continuation of class 3 suspension system. So in this suspension system we are going to learn what are the requirements of suspension, torsion bar suspension system, leaf springs, coil spring, independent suspension for front wheel and rear wheel, and what is the working principle behind air suspension system. So what is the main objective of this suspension system? So the ability of the vehicles to negotiate rough roads and handle well at high speeds is mainly due to the proper design of suspension system. If the axles are bolted directly to the body, what happens? An uneven spot in the road would transmit a jerking force to the vehicle, which in turn results in discomfort for riding. Hence, automobile chassis is mounted on the axle through springs. This is done to isolate shocks on the vehicle body from road. Okay. So we are going to learn the different the types of suspension system. So let us learn what is main objective. So that to prevent the road shocks from being transmitted to the wheel components, thereby providing suitable riding and cushioning effect to the occupants. So to provide stability for the moving vehicle during pitching or rolling. So provide safe vehicle control which is free of irritating vibrations, reduce wear on tire. So you can see here the different loads are acting here on the vehicle. Okay. So otherwise it is how exactly the pitching or the bouncing will take place here. So there is a vertical loading, there is a like the upward loading will be the okay transverse pitch, okay longitudinal, then rolling. So these are the different types of what exactly I can say the different types of loadings will be acting on the vehicles. So the center of gravity of the vehicle will be a certain height above the ground level. So the turning couple about the longitudinal axis of the vehicle will be induced during cornering. So while turning, cornering force will be there because of centrifugal force acting at the center of gravity and forces at a tire road contact surface. This results in a motion called rolling. This is what the rolling takes place. This causes the left hand suspension move out of phase with the right hand suspension. The tendency of the front portion nose of the vehicle to dip due to the braking is known as brake dip. So otherwise the brake dip will be there. There is one word. Okay. So the bouncing is the motion of center of gravity in the vertical direction. It can be front end or rear end bounce. Okay. Diagonal pitching is the combination of pitch and roll. So these are the different types of how exactly the forces, lateral force, okay, like pitch due to drag and lift, then lift force, okay. So different types of forces how exactly it will be acting. Okay. So what are the requirements of suspension? There is vertical loading, rolling, brake dip, side thrust, handspring weight. Okay. So these are the different requirements will be there in suspension. To reduce pitching tendency of the vehicle, the frequency of the front suspension should be less than that of rear suspension. So this is very important. Okay. To reduce pitching tendency of the vehicle, the frequency of the front suspension should be less than that of rear suspension. Rolling, so already I told you, the center of gravity of the vehicle is above the ground. While turning, the centrifugal forces acting outwards, while road resistance inward, giving rise to couple stabilizers are used. So brake dip, nose dips while braking. So while braking, what happens? Like that is called as brake dip. depends upon center of gravity position relative to the ground. Side thrust absorbed by rigidity of the springs. Side thrust. So unsprung weight, weight of the components between suspension and road surface. They store vibrational energy during shocks and later transmit to the sprung parts. Okay, miscellaneous soft and hard suspension. These are the requirements of like the suspension system. So there are two types of the suspension will be the rigid axle suspension, and one is independent suspension system. Okay, so you can see the parts. So steering wheel from bottom, steering column or drive shaft, like steering gear, diaphragm, all these things were discussed in earlier classes. Then drag link, steering arm, track rod, kingpin, axle beam. So this is rigid axle. Means axle beam will be rigid here. So it will be moving in forward direction. Okay. So there is no independent. Means it is not separate. In all the vehicles nowadays, it is like independent. It is not rigid axle suspension. Okay. So if you see independent suspension, you can see here. So steering wheel, steering column, steering gear, diaphragm, like a relay rod. There is one relay rod. In previous section we have seen two relay rods. So again, the tie rod and wishbone arm. Okay. So these are exactly the tie rod is separate here. Okay. Then these are called as something about independent suspension system. Suspension system will be different here. Okay. So already we have discussed what are types of suspension: rigid suspension and independent suspension. Okay. So types of suspension here, again you can see the diagram here. So if you see the first diagram, the first figure. So both tires are contact to the road surface. Then if there is a bump comes, okay. So if you see there is one bump will be there. So whole wheel will be lifting. You can see there whole the chassis of back rear end or the front end will be moving upward. Whereas in the second figure you can see here, this is called as first one is called rigid suspension. So bottom you can see independent suspension. So suspension will be independent here. For this one tire, separate suspension is connected. Okay. So when the bump comes here, okay, then you can see only the tire, one tire of right hand side will be upper side, whereas all the second tire, okay, it will be entirely to the road surfaces. Okay. So this is what the independent suspension and the rigid suspension will be acting like this. Okay. So you can say independent. Okay. So only the left wheel, right wheel will be moving upper side. Okay. Other wheel is not affected here. Whereas here both the wheels will be tilted in non-independent suspension system. Okay. So in suspension system again there is like coil springs and there is a leaf springs will be there here. So exactly you can see the figure. Okay. So what is exactly this coil springs? Okay. So stabilizer will be there, coil spring you can see red color, shock absorber, inside shock absorber will be there. Okay. Then upper control arm, then ball joints will be there. This is coil of exactly will be provided, and in this figure you can see the leaf spring. Okay, the red color you can see that is called as a leaf spring, and again it is connected to shock absorber. Okay, so the coil spring is the most common type of spring found on the modern vehicles, almost all. Okay, leaf springs are now limited to the rear of the some cars because for heavy loads these leaf springs can be used. So now, what are the types of springs? So coil spring, leaf spring, A spring, and a torsion bar. Okay, you can see the coil spring, you can see the leaf spring, you can see the D figure. Okay, torsion bar, and you can see air spring. Air will be inside. Okay. So what is exactly this torsion bar? It is a simple rod which is acting in torsion and it takes shear stress only. Okay, it takes shear stress only. It nearly stores the same amount of energy per unit weight as that of coil springs. So torsion bar is often used with independent suspension system when compared with other systems. It is lighter and occupies less space. The wheel arm is connected to the wheel hub. When the wheel hits a bump, it starts vibrating up and down and produces a torque on the torsion bar, which acts as a spring. So when the wheel arm is connected to the wheel hub, when the wheel hits a bump, so when the wheel like bumping takes place, it starts vibrating up and down and produces a torque on the torsion bar, which acts as a spring. So the disadvantages include inability to take braking thrust and absence of damping. So you can see this torsion bar. Okay. So frame, torsion bar, then wheel arm, then bearings, axle chasing, wheel hub. Okay. So again, this is what exactly the torsion bar will be. So, so you can see clearly in next figure. So this is how the bar resists twisting action and acts like a conventional spring. You can see here, these are called as the torsion bar. So you can see clearly here. Okay. The shaft that is connected here, this is called as torsion bar. This one. Okay. That is called as torsion bar. Okay. And these are called as two types of torsion bars. So how exactly it is provided. So when the bumping takes place, okay, that shock will be taken by these two rods. It will act as a spring. Okay. So that is what the torsion bar. So this is torsion bar. The bar is a twisting action. So when the vehicle bumps, that is twisting action will be takes place, acts like a conventional. As you can see here, this is called as exactly the torsion bar. Then what are the advantages and disadvantages of torsion bar suspension? So light in weight, less space, maintenance less, initial cost is less, ride effort is more. Okay. So it does not take accelerate and braking thrust, so required additional linkages. Due lack of friction, damping is necessary due to road shock. So compulsory damping. Okay. So what happens due to road shock, damping like other devices, other linkages are required here. So applications SUV, Tata Safari, Tempo, Trax, etc. Okay. So suspension springs. So function spring stores the energy when deflected by the bump on the road. On releasing, it extends to the stored energy, vibrating with some frequency. Amplitude of vibration decrease exponentially. So there are different types of springs will be there. One is called as steel springs. So in steel springs again, leaf spring, tapered leaf spring, coil spring, torsion bar. These are called as steel. It is made up of something about the material called steel. So rubber spring, compression spring, okay, steel reinforced spring, progressive spring, phase shear spring. So air spring, so bellows type and piston type. These are the different types of springs. So first one is called as something about leaf or like or laminated springs. Okay. So the leaf springs already I told you it is made up of steel. Okay. So these are commonly used in automobiles, rear suspension, especially when the load is more. The leaves are held together at the center by a bolt which passes through holes in the leaves. You can see the rear axle, U-bolt is connected. So there is one master leaf will be there. Okay. Then many leaf springs have like special springs have special insert between the leaves to permit the leaves to slip over one another when the spring bends. Okay. The spring leaves are graduated length are shown. Okay, the front end of the largest leaf is bent into a circle to form a spring eye. There is one spring eye will be there and is attached to the spring hanger. Okay, so spring hanger will be there by a bolt. So rubber bushings are used to provide the insertion to the bolt from the spring hanger. So the rubber bushings serve two purposes here. So observe vibration and thus prevent it from getting up to the vehicle's frame. So allow the spring eye to twist back and forth as the leaf spring bends. Okay. So this is what the simple explanation behind the leaf spring. You see the diagram exactly. This is what the leaf spring that is connected. Okay. So most of the vehicles it is connected the rear end. Fine. So you can see the front spring of Ashok Leyland bus. So this is Ashok Leyland, how exactly. Okay. So this is the rear spring of Ashok Leyland. So there is front and this is rear. Okay. So this is types of leaf spring. One is quarter elliptic, semi-elliptic and transverse. Especially in small vehicles, these types of systems are provided. Okay. So front axle. Okay. So you can see the different types of springs. These are called as leaf springs. Okay. Semi-elliptical leaf springs are commonly used in light and heavy commercial vehicles. The spring consists of leaves, blades, varying length. Okay. So the blades are bound together by means of steel traps. Okay. So next comes what is coil springs. Okay. So you can see the figure, the coil springs. Okay. Then rear axle bearing. Okay. So nowadays, coil springs have become very popular because of limitations involved in leaf springs. Okay, shows a front suspension system using coil springs. Okay, in the figure shown, the coil spring is held between a spring seat in the car frame and a lower control arm. Okay, the inner control arm are provided with the car frame on the car frame. Okay, the ball joints used to allow the steering knuckles to swing to the left or right for the steering. Okay. So this is assembled. The wheels are mounted from left to right towards the front wheels so that the car can be steered. So this is simple the figure of this coil springs. You can see here the simple coil springs, how exactly it is provided. So coil springs are mainly used with independent suspension system. They are also used in conventional rigid axle suspension system. So the energy stored per unit volume is almost all double compared to the leaf springs. So that spring takes a shear as well as bending stress. So this is very important. So coil springs are unable to resist torque, reaction and side thrust. Whereas in torsion bars we have seen it takes torque. But here coil spring cannot resist the torque reaction or side thrust. So what is shock absorbers? So flexibility and stiffness, higher flexibility results in continued vibrations. Okay. Then higher stiffness results in decreased shock absorption. So also damping characters for a given spring varies. So excessive flexing can be prevented by using dampers or shock absorbers. Okay. So shock absorbers are either friction type or hydraulic type. Friction type is almost all obsolete. So you can see the principle of operation of hydraulic shock absorber. Okay. So shock absorbers are necessary as the springs do not settle down fast enough. That is very important. In other words, after a spring has been compressed and released, it continues to shorter and lengthen or oscillate for a time. Okay. If a wheel of car hits a bump, the spring compresses, then the spring expand after the wheel passes bump. The expansion of the spring causes the car to be thrown upward, okay, or low, having over expanded. The spring shortens again. This action causes the wheel momentarily leave the road and the car drops down. The action is repeated until oscillation gradually die out. Such a spring action on the car would produce very bumpy and uncomfortable ride. It would also be dangerous because of the bouncing wheel would make the car impossible to control. This would be especially dangerous on the curve. Okay. So therefore, such that a device is needed to control the oscillating action of the spring. This device is known as something about shock absorber. Okay. Sort of many types of shock absorber available, such as vane type, opposed piston, telescopic shock absorber is most commonly used here. So let us discuss what is exactly this telescopic shock absorber. So the principle behind, when the piston forces the fluid in the cylinder through an aperture, high resistance to the piston movement is developed. So damping is proportional to square of the speed. So this is what the telescopic. So in exam you have to draw this figure. Okay. So A is inner cylinder. Okay. So you can see the A. So A is inner cylinder, then B is outer cylinder, then 1 to 2, two-way valve. So 3 is piston, 4 is gland, 5 is head, and 6 is eye connected to axle, eye connected to the frame. So this is telescopic shock absorber. So how exactly this, like the simple explanation behind. So in this piston, rod attached to the two-way valve, okay, 1 and valve 2, which is also two-way valve, is attached to between cylinder and the tube as shown in figure. Okay. The inner and outer cylinders are filled with oil. The inner and outer cylinders are filled with oil. When the vehicle comes across a bump, now the eye connected to axle will move up. With this, oil below valve 1 will move up. So due to the resistance to the flow of oil through valve 1, it exerts pressure, okay, pressure on valve 2. Okay. This allows oil to flow through valve 2 also. So the flow of oil through valves 1 and 2 will be slow because of damping effect. In the similar way, for downward movement of the eye connected to the axle, because of road irregularities, the oil will move from upper side of the valve 1 to the lower side and vice versa. This is what the system will takes place. When it moves, when there is a upper axle, so it will move up and down vice versa here. Okay. So this is what the simple explanation behind the telescopic shock absorber. Okay. So suspension shock absorbers. Okay. This is what shock absorbers you can see. Limit spring compression, extension movement to smooth the vehicle's ride. So you can see the shock absorbers action. Okay. So you can see the piston, rod, reservoir, bypass spring, restriction ports, piston, compression head orifice, compression head. Okay. So first figure it talks about the compression. You can see clearly when there is a compression. So that is what the system you can see clearly. So when there is like extension, okay, so you can see the figure. So types of independent suspension system, there are two types. One is Mac-Pearson strut and one is like wishbone type. Okay. So you can see here the front wheel independent suspension system. Okay. So five types. One is wishbone type or parallel type, Mac-Pearson strut type, vertical guide type, trailing type. These are all things are not there. There are only two things will be there for our syllabus. One is wishbone type or Mac-Pearson strut type. Okay. This is what the wishbone suspension it will be. The suspension must be designed in such a way that to keep the wheel upright for a maximum tire contact. Okay, vehicle control and to minimize tire wear. So the upper wishbone is short and the lower wishbone is longer. You can see here. Both wishbone pivots and lengths are calculated to provide best operating angle for a given suspension momentum. So for a given suspension momentum, so this is required. Okay, this is called as wishbone suspension. So you have to draw the figure. This one, wishbone type suspension. So upper wishbone and lower wishbone. Then there is a shock absorber. Spring will be there. Okay. Then there is kingpin. So this is Mac-Pearson strut type. Simple than double wishbone. Okay. So lighter and reduced unsprung weight. Camber does not change when wheel moves up and down. So gives maximum room in engine compartment. Used commonly for front wheel drive cars. So this is wishbone and you can see the simple figure. So these are something about Mac-Pearson strut type. So front suspension, this is also Mac-Pearson strut. So exactly you can see. So shock absorbent springs, steer link, car frame and lower car. So advantages, wishbone type, ride quality is good, improve steering. Okay. So ground clearance increases. So application in SUV vehicles. Okay. So initial cost is more, maintenance cost is more, required frequent wheel alignment, otherwise increased tire wear. This is vertical guide suspension. So kingpin attached directly to the cross member of the frame. Okay. Disadvantage of limited stability. This nowadays it is not used. Okay. Rear wheel independent suspension system. So independent suspension system parts. You can see. Shock absorbers or dampers, control arm bushing. This is something about Didon axle. This is also independent suspension system. So trailing link independent rear suspension. So trailing link, you can see the design. Maintains camber of the wheels. That is what you need to understand. Always lead to understeer. Link roll the same degree as the body during cornering. Both wheels lean towards outside of the corners. This is what the figures you can see. Now comes the what is air suspension. Okay, so this is what the layout of air suspension goes. Okay, so one is the front wheels will be there. You can see the figure. So front air springs. Okay, leveling valve. Then a lift control valve. Then again air from atmosphere, air filter compressor, air accumulator relief valve, then return line, supply line, then leveling valves. Okay, then rear wheels. So air or pneumatic suspension is incorporated in some tourist buses, especially in Volvo buses. Okay, so this type of air suspension will be accommodated to to improve the riding of comfort for the passengers, especially you have seen in Volvo buses. So when the vehicles, okay, so all it is of air suspension only. Okay. The air suspension system possesses the following advantages over conventional metal springs. So what are the advantages of air spring over metal springs? The spring rate varies much less between laden and unladen condition that decreases dynamic loading. Changes in headlamp alignment due to changes in the load are avoided. It improves riding comfort for the passengers. Longer service life for the vehicle due to improved smoothness of the run. Okay. So in air suspension system, what exactly will happen? 4 air springs or airbags. Okay, it is otherwise it is airbags which may be of bellows types or piston type are used instead of coil springs. So the atmospheric air passes through a filter. So you can see here. So the atmospheric air passes through a filter and a compressor raises its pressure to about something. It will be there. So there is some value will be there. Okay. So air enters through the air filter and it enters, and the compressor raises its pressure. Okay, it will be in kg per mm square, and air at this pressure is accumulated in the accumulator. Okay, then air from accumulator tank. Okay, the relief valve is in the accumulator tank acts as a safety valve. The high pressure air then enters to the air spring through a lift control valve and a leveling valves. So this is how the air rises its pressure. It enters through the lift control valve, and through that lift control valve it enters through the leveling valve. Automatically it will try to raise the vehicle. This is what the simple explanation behind the air suspension system. Okay. Then, so advantages of air suspension: the variable space for wheel deflection is put to optimum use by virtue of automatic control devices. Okay. Reduces dynamic loading, improved riding comfort. Spring becomes stiffer when compressed, providing comfortable ride under all conditions. Thank you, students, for your attention. This completes your suspension system. Thank you for your attention.